got a light up above here, and I'm going to pull this relay carrier out. It's held in with a small clip, and what we can find are two relays, 614 and 614. And if we remember back to our diagram, I'm sort of a little bit worried. There's some signs that that relay's been out before, and in fact this car has had two other repair attempts made on it, and it's had, the lady said, various components being fitted. So I think some solenoids and some sensors. So this could be something to do with the fault that we've got. I had a quick look round, and it's been ongoing, this fault, the lady says, for about 3 years. So there's no sign of anything new as I did my visual, but she has had some attempts at repair being done. If I go to the back of the relay carrier, what we can see, and in terms of confirming the position of the relays, we've got two relay carriers. The heavy duty current carrying wires are red and red with a grey trace, and on the other one they're red with green. So what I'm going to do is just going to flick back to the diagram here a sec. Flip back to the diagram, back. Because the position of the relay holder can sometimes be slightly dubious, that you're not quite sure if the relay was this way or this way. But by looking at the wiring colours, we should be able to define exactly what we've got there. I'm just going to scroll down to the page, and in fact, let's have a look. Our wires coming out of that component supply relay are green. So we have a red wire going in, 4mm, and a green 4mm wire coming out the other side. So let's identify the correct wire. Let's grab the jolly old multimeter, and we'll take a quick look and see what's the story. Okay, so multimeter in stun mode, no, multimeter into volts, and if I have a look at the pins we've got there, I've got two pins there, so I've got an in and an out, so we can reference this to a ground, and we can see we've got 1204. Let's just have a quick look. We put that somewhere. I'm going to get a clip for that so we can actually see what's going on. Okay, you can see that on the multimeter. That's good. Let me just get a little clip. Well, in fact, I've got one of these things. This is a magnet clip, so I'm going to pop that one onto there, and then clip that somewhere metallic. We find something magnetic here. Let's find something betterly magnetic. I'll tell you what, here's the terminal for the battery. That will do. 1205. Okay, let's have a look at the other wire. So that's my main in wire. Of course, I don't know if that relay switched on or not, how it works. Okay, and on the other pin, coming back up that wire, we've got 3.46. Remember, that green wire is the one that's going to our components. So that should be the feed to the components. Okay, let's just flip the ignition on a second. So I'm going to ignition off. I'm going to count to 2 or 3, let the ECU go to sleep. We should see that voltage disappear. Now that voltage is very interesting in that it looks like a diagnostic voltage. And what I mean by diagnostic voltage, this is a voltage that comes out of the ECU through the components and back up the supply wire. And of course we're measuring the wire, oh there we go, it dropped to 0 now, the ECU switched off. Because we're actually measuring the wire that comes from the components at ECU through the wiring to the component and back up to the relay, by that virtue, we can see there's a voltage coming back up that wire, and this is a detection voltage. This is how the ECU works out, whether or not you've got a voltage going down that wire. Ignition on, ECU wakes up, 3.74 volts. I'm going to crank it, and as soon as the ECU wakes up and sees a crank, I'm expecting that voltage to increase to battery volts. There we go. So the relay's latched. And the relay's latched and supplying us now 13.7 volts. 13.8. And if we measure the supply side to that relay, we should see exactly the same thing. 13.77, 13.78. Now this is the relay being measured dynamically under load. So we have a pull of current on that wire, and that tells me the supply is good and also the ground is good. So at the moment we don't have a fault there. What we did notice after we cranked the engine over, I'm just going to try and rev it up now. Okay, so we're only getting 3,500, 4,000 revs. And what we notice is the lady's description of that fault, let me just switch it off a second. The lady's description of that fault, there's the relay still latched in, give it a second and it should unlatch. There you go. ECU still awake, diagnostic voltage, and the ECU goes to sleep. Very interesting. The lady did say, depending on when you crank it over, if the fault's going to happen, it happens just straight after the crank. And what we noticed was the relay didn't actually latch. There was a delay in the latching. And the delay in the latching meant that it didn't jump up to 12 volts until maybe a second or two later. I'm going to run that test again. I'm going to let the relay go to sleep. We should hear it unlatch. Let's just make sure I switch the ignition off. Ignition's off. Let's hear the relay unlatch, drop to 0. And what we saw, there was a bit of a delay between us getting our 12 volts on the other side of that relay. 3.74, 3.46. Give it a second, should pop off. Should hear a click and a whir. And then we'll just try that again. We'll pop the ignition on, we'll crank the engine over, and we'll see if this is a delay, a characteristic delay in it getting 12 volts. So you would think and you would expect, engine management unit cranks over, sees a cam, sees a crank, sees the start authorization, it should latch that relay. And remember that relay is supplying fuel pressure control, fuel pressure regulating solenoid, which is a pretty important one. So let's pop the ignition back in. Let's crank it over. Let's try that once more. Ignition off. 3.46. Key on, engine off. Crank it over. Okay, that time, the third time, it jumped up to supply volts much more quickly. Ignition on, cranking over, 1 second, 2. So within 1 second, that time, within 1 second, key on, cranking over, 1 second, almost immediately it's latching across. But the first time we did it, it was sluggish. It didn't latch across straight away. There was a second or two's delay. Okay, so now we've got to work out why that is. What we're going to do now is check the switch inside. So almost before the engine starts up now, the second, third and fourth time, it's latching. Okay, so I need to check now the control side. So I'm just going to have a quick look at the control side relay. So we've got a SW, a black and a blue wire going in, that's the supply, and a red, the red and blue wire going out the other side. So red and blue is being grounded by my control unit. So let's have a look here. Okay, black and blue, red and blue. So this is my ground side. So I'm going to do the same thing again, back probe this, and what we'd expect it to see is that being pulled to ground. So when that's latched in, that should drop to 0, or as near as 0.8 of a volt. Wow, 1 volt hanging up on that wire. Okay, so let's just check out 12.4. Let's crank it over once more. 0.85, 0.86. So that's being grounded. Okay, I'm just going to continue to check the supply because we haven't checked the supply under load. So this is for the control side on the supply. 12.4. I'm going to crank it over. And we've got good healthy supply with that relay latched in on that side. I'm going to try it again a couple of times. I'm going to try it once more to see that we're not losing. No, that's latching again. And it's latching again. Okay, so I'm going to measure now the output side once more, see if we can get that. Okay, so I think we've seen the behaviour now. I'm just going to stop the video here and reframe and just summarise what we've got to this point. So we can see from the tests that we've just done on the vehicle that we do have a bit of delay in the latching of the relay. So just by way of a summary, what we're going to do, we're looking at this relay here, J757. That pen's a bit weak, so we're going to have a change colour. Hang on a second. 757 is the relay that we're interested in. And what we've measured is this wire here, which goes to my components, and we've got a voltage on that line. We're hoping that, well, we've seen that when this line here is latched, this wire here, let's write that in another colour, has got 0.8 of a volt when it's latched and pulled down by the ECU. And we've seen a delay, so when this wire is pulled to ground, there is a delay of a couple of seconds between this high side of the relay latching shut and providing our energy path to our components. And we think that this delay is what's then setting the codes and dropping the vehicle into limp mode. There must be a diagnostic monitor inside the ECU that sees that delay to the power supply and runs in limited operation mode. What we're going to do, just to try and prove now, potential causes of that delay are going to be either we have a voltage issue on the low side, so there's some level of resistance, and this could be, we know it's not in the supply because we've got 12 volts. It could be in the coil, that could have an issue with the coil, or we could have an issue with our 0.8 volts on the pull down side, so that could be causing an issue. What we could do is measure the other pull down that we've got here. The other pull down value that we've got here, if we're also getting 0.8 on this wire, separate pin to the ECU entirely, we know 0.8 in terms of an order of magnitude as a control voltage drop on that wire is okay. We could give the engine ECU another ground and just see if those 2.8 volts drop, but experience says, you know, up to sort of, you know, 0.8, 0.9 of a volt through a transistor control on this side of the relay is okay, but we'll just confirm. What I want to do next is I'm probably going to get two multimeters. So I'm going to put multimeter 1 measuring the supply output, meter 1 there, and then I'm going to measure meter 2. I'm going to measure the control side of the wire, and we're just going to see, what we're aiming at seeing here is if the control side is pulled to ground, the engine control unit then has done its job, and if there's a delay in the latching across, we would have to have an internal problem in the relay, probably in this control side. So I'm going to pull 2 meters up, do that test, crank the engine over, and just see what gives, see if we can work out if there is a delay or in fact what's going on. But we will also validate that we've got the same voltage drop on the main relay that we have on this, our suspect relay, if you like, and that will be our next step. So here we are back on the car. I'm going to put 2 meters on here now. I'm just going to, I've put 2 little post-it sticky notes on there, if you can see that, and the idea is so we know which meter's which. So I'm going to hook another meter up to the ground. Put the right one onto the ground, and then I'm gonna put this one into the output voltage. So we're going to look at, that's a control wire there, and then the output voltage is the green wire as seen on the diagram. And let's have a quick look, make sure we've got that in the right connection there. Ignition off, ignition on. It's not in the right wire. Let's have a look here. Oh, it's just dropped off the ground. Put that on the ground. Onto volts, onto volts. Let's just make sure they're both reading. Okay, there we go. So we're in the wire now. So this is the wire going down to the components, and this is the control wire being grounded by the engine ECU. So what we're looking for now is some sort of delay or otherwise. So let me just move these stickies down here so you can see roughly what's going on, but they're not getting in the way. So let's crank it over and see what happens. What we're expecting is this is going to 0, this is going to battery volts almost immediately. Okay, now we can hear the symptom being exhibited. Okay, so that's quite clear. What we're seeing there is the voltage is being pulled down quickly on this meter, going to 0. The output voltage from the relay is taking a long time to switch across to give us output to the components, and the vehicle's running very badly and making, you know, quite a noise. So evidence, if we need it, that the relay is being given the instruction by the engine ECU, pull it down to ground, and the relay is slow in latching across because the output voltage isn't increasing as it should. So I think we're pretty sure that we have got a relay fault there. So next step is to replace the relay and run that test again. Okay, so we've got a new relay. I'm going to pop this relay in now. I'm just going to switch the ignition off. I'm going to use a small hook tool with the ignition off. We can wait for the battery volts to drop just to stop us shorting out, or if we're comfortable with what we're doing, there, it should be unlatched there. We can disconnect this relay and take it out of the holder. There we go, and what we see then is diagnostic voltage on the other pin now, because the relay's wondering where on earth it's gone. Sorry, the control unit's wondering where the relay's gone. If I pop that back in, we should get 12 volts restored. Now, if we do that crank test, what we're expecting to see, this one to drop to 0, and that one to go up to 12 volts. So key on, engine off, crank it over. Okay, and what we can see then immediately, this one's dropping and this one's increasing to battery supply volts. I'm going to try that again. I'm going to pop the lights on to give it some load, drop that battery level down. Let's get that down, so cranking over again. Okay, so drops to ground and straight up to battery volts. Let's try that again. So what we think is the windings in the relay are not pulling the latch across by the look of it. So let's try again, crank. Okay, so again, before it starts, we're up to battery volts. Let's try again. Okay, and again, drop from battery volts, it's pulled to ground, and this one latches and we get 12 volts on the output. Same again. So we'll let the battery volts drop a little bit more. So we've got 11.58, 11.7. I've got the headlights on to create some load. Let's try again. Okay, in all cases then, in the last 4 or 5 attempts, we're seeing now absolute synchronicity. So this one is pulled to ground and this one latches, which is exactly what we'd expect, what we didn't have previously. So even with the battery volts down at 11 volts, which is simulating, you know, cold battery and low battery energy, our new relay, the new relay is latching in absolute synchronicity as we would expect. Okay, so I'm not going to continue to do that because I think we've it looks like we've got a fix there. I'll stop the video now. I'm going to run that a few more times just to confirm, and then we'll summarize what we've got. Okay, just by way of comparison, I thought we'd measure the old and the new relay. So we've got the two relay styles here. I'm going to put this meter into multimeter mode. I'm just going to measure the primary or the control side windings. Of the new relay is 61. And of the old faulty relay is 54. And I think if you were doing a relay test off the vehicle, 61 versus 54, so 6 ohms is 10% difference, you know, around about. It's probably not enough for you to diagnose that relay as a fault if you took it off the vehicle and checked it statically, which again, you know, goes to prove that you know, dynamic testing of the system is you know, is absolutely key and critical to working out the root cause. Okay, so one other test we were going to do, now we've got two control sides, so what I'm going to do is take the stickers off there. So now we're measuring the control side of our component distribution and the control side of our main relay, and we're going to crank the engine over now, and we're going to see that the voltage level on those relays is, when they're both latched in, is somewhere similar. We've got 0.10 of a difference in my engine management as opposed to my power supply relay, but in terms of order of magnitude, they're somewhere close to each other. The meter switched off at the end, and obviously this one remains latched in, you know, most of the time. But in terms of a test with them latched in, we've got 0.8 and 0.88. So again, about 10% difference between the two relays. So what we were trying to do is just confirm order of magnitude there. That one relay is very, very similar to the other. So for the final part of our test, we're going to fire back into the vehicle system using the Arbritas AVD. I'm going to communicate back with the vehicle. We're going to pull the codes from engine management, control unit master. We're going to look at the codes that are in there. We're going to clear the codes that are in there. We're going to reread the trouble codes, no errors, exit. Okay, and then we're going to just crank the engine over a few times to make sure we've got that symptom's not returning. One, two, 3, 4, 5, 6. Okay, so 6 times crank it over. We've got the lights on again, allowing for some voltage drop and seeing if that's affecting the system. If I go back in there now, open that system up, pull the trouble codes. Okay, so we've got no errors. So at the moment, I may probably keep the car here for a little bit longer just to prove and validate that that's okay. Maybe start it again tomorrow in the morning. But so far, that looks like we've rectified that issue. So guys, by way of a quick summary then, I just detailed on the board what things we did. So for the TFSI diagnosis, we initially investigated the information from the customer. We did our pre-diagnosis. What were the symptoms? How often did they occur? What was the overt symptom from the vehicle? And we tried to build a picture of when and what happened and how it happened. Then we had the vehicle in the workshop. We did our visual inspection, checking around, make sure you see nothing's rubbed through, chafed or fallen off. We did our symptom verification. Could we get it to repeat itself? And it did, so we could understand exactly, matching back to what the customer said, this is what we were seeing. Tying those two things together give us a good position to aim at. We verified the symptom, then we did serial data analysis. So we asked the computers on the car what they thought was going on. And this step is a bit of guidance. We're not going to replace a component because serial data stream came up with trouble codes for those 4 components. I'm not sure if in the past one of the other places that have looked at that have changed components based on trouble codes, but those trouble codes, as we saw when we moved on to the next step of the diagnosis, gave us a clue as to what was wrong. Then we checked the diagrams. So we looked at the diagrams, wiring diagrams on Audi, against the serial data streams of the diagnostic trouble codes that we got from Arbritas, and there was a correlation there. We were checking for correlation. Is there anything common that joins these faulted components up to the wiring diagram or the structure of the way the vehicle's wired? And we found that relay. So then it was down to test and measurement. So we think there's a correlation, relay supplied fuses. We worked through the diagram and said, yeah, okay, it looks like a relay is controlling that. We did our test and measurement, so we validated the function of that relay. And what we found was the relay, the control side was being grounded, but the switch side was sluggish. And we felt then the vehicle, because there was a delay in powering up those components, the engine management unit freaked out because it wasn't achieving its goal as set within its parameters, and then it was running in limited operation mode. And we verified then with the 2 multimeters, is it getting a switch, and did it switch? And what we found was there was a delay. And so we verified the root cause. We ruled out problems with the ground and the power, and through those couple of tests and in conjunction with the diagram, we said, no, it looks like it's got to be the relay because of what was happening. And then we replaced the faulty component with the relay and we verified the fix. So we measured again what was happening. We tried to replicate the symptoms. The symptoms weren't in evidence, so we're classifying that as a fix. And these steps really were what we undertook to sort that problem. So once again, I'd like to thank you for watching. I hope you found something interesting in this video that maybe help you in your diagnosis, and we'll see you next time.